Good evening, Buddha. Good evening. I hope all are fine. आज first to report a very active girl. I hope there's enough light on the board and my voice is audible. I hope you all are fine. I welcome you to my class, 10th ICSC. Topic is same, circulatory system. So before I start, just let me know my voice is fine, it's audible, and there's enough light on the board. Okay. Audio video clear. Okay, that's good. Fine. Let us start then. So I was here yesterday. I talk about this. Okay, I explain you about this part plasma. I told you serum. I told you about if you from plasma, if you take out fibrinogen, that part is called serum, and this is a composition of plasma. 55% of the blood, and in plasma 90% water is there with these following components. This is something very important to understand. And let's understand the next part of the blood, that is RBC, WBC, and platelets. Let us understand one by one all. If you talk about this RBC, I am telling something about the RBC. If you talk about the front look, from the front look, it would look like this, and side view, it is a front view, and this is the side view. This is the side view of RBC. And I hope तुम लोगों ने वो खाया होगा ना, पेड़ा होता है, पेड़ा पेड़ा सेंटर पार्ट में थोड़ा सा डिप्रेस होता है, डिप्रेशन होता है उसमें थोड़ा सा पार्ट, और साइड से ऐसे दिखता है. So in RBC you know about this. My point is to understand lifespan. You should know about lifespan of RBC. Would be asked in examination, that question. Just keep in mind the of 120 days. Today I could see only one student. What happened? Today other students are not there. Archika, today only you are the student, or other students are also there? Okay, fine. And one thing please keep in mind about RBC. These RBC they lack nucleus, they lack mitochondria, they lack endoplasmic reticulum. So this is something very important about RBC. If you talk about RBC, in mature RBC, nucleus is absent. Even it is a cell. These are three cell organelle. These are three cell organelle are absent in mature RBC. I repeat, nucleus is not present, mitochondria they are not present, and even endoplasmic reticulum, these all are absent. Kashik, Ganesh, okay, good evening. Shangarika, hello girl, okay, that's good to see you all. Fine, okay, good to see you all. Good, okay, fine. So, but I want only one thing. I will try my best to explain things to you. In between, something is not clear, please ask so I can help you. Okay. Sorry. Okay, fine. Okay. So let me tell you, there is a reason why these three cell organelles are absent. So one thing, if you talk about this part, they can, they it it increases the surface area. This is the main part. So they can absorb more oxygen. So first reason is very important. This number one reason, number two, and number three. It increases the surface area. They can absorb more water and more RBCs can be accommodated at the same space. This is the main reason why the RBCs lack nucleus. These questions may find place in examination, so you should know this. Number two, mitochondria absent. So why it is important? Because as RBCs in the blood, if you talk about this is the blood, and these are RBC. These are RBCs, and in the blood plasma, there is food in the form of glucose. Okay. So if this part is blood, understand this. Okay. So whatever present in blood, it is plasma. This part is plasma. As I told in plasma, food is there. So this mitochondria, if mitochondria would be present here, it can use this glucose. So one point, glucose of the blood cannot be used. So whatever glucose is present in blood can be completely transported to other cells. Therefore, it is absent. Number two, oxygen of the RBCs cannot be used. 2 points are very important. So I don't know how things are so systematic. See, we study, but God made all these things so systematic. We will study, understand, and we get surprised, and then praise always God for these things. Okay. So my point is this: in RBCs, this cell organelle, that is mitochondrion, it is also absent because in the blood glucose cannot be used, and in RBCs oxygen cannot be used. Point number two. And if you talk about point number three, this endoplasmic reticulum, let me explain this part to you. Suppose in any cell, you must have studied it, it gives shape and flexibility. These are called endoplasmic reticulum of any cell, plant or animal. This part is nucleus, any cell. So it means as long as this is present in a cell, it cannot be compressed more because the attachments are there which would stop the compressibility of any cell. If these endoplasmic reticulums are absent here, so it provides flexibility. Absence, I repeat, absence of this cell organelle provides flexibility to RBC, and it pass through can pass through narrow capillaries. I hope to hear I'm clear. Kritika, Maheshwari, good evening. Good to see all of you. So I need to help all of you. Please let me know. I gave you reasons just now that in RBC these three cell organelles are absent, but it has a reason that why they're absent. I have written reason one for the nucleus, second for the mitochondria, and third for the endoplasmic reticulum. It has some reason why they are absent, and they're making RBCs more efficient. Okay, so it making it more efficient. With absence of these organelles making RBCs more efficient. So I hope up to here it is clear what I explained. Shingarika, yes, thanks. But just this is enough. This is enough. You talk to me like this. I'm very happy. It's give me also a clarity. So okay, that's good. This is clear to you. Next topic. You talk about class platelets. First thing you should know, they are so important for clotting. Platelets. Let me explain this part to you. You understand better this way. If we have any cut, a long cut is there nearby wrist, because whole body, whole body we have excess of these blood capillaries, and if any cut is there in our skin, and the chances are that there are a big cut or a minor cut would be in our blood vessels, and there is bleeding. And if suppose this part is open, this wound is open wound. If any wound is open and we are not able to cover, or suppose we that time a victim is fallen unconscious, so and from this cut part, because in our body heart is pumping, because the pressure of the from the heart through the blood vessels, blood would come out with the pressure because cut is bigger. And if nothing is taking care of this victim, a person would bleed to death. Therefore, for this, in our body, we have a mechanism with the help of platelets. Something happened here that with the help of platelets, they are making a network of cells here. A clot is formed. Clot means is actually plug this area with the help of cells, and it stops bleeding. So this mechanism, it is our inbuilt mechanism which could help us save us from bleeding. And just because of this, even if you have any wound and nothing you have, you just cover it is with the hand, and after some time there is formation of clot, and after within week you would be fine, even without any medicine. This all is inbuilt mechanism of the body that is called clotting with the help of platelets. Okay, so let me tell you about the mechanism. Let us start understand this. Whenever there is an injury or any part is injured, that time that time only this mechanism of clotting is activated. Whenever this injury is there, at that time there is release of they are called thrombocytes. Thrombo means clot actually. Okay. They are called for clotting, so they are also called thrombocytes. A clotting is also called coagulation. Why I'm telling you these terms, please keep in mind. These platelets are important for clotting, therefore they are also called sorry class, let me thrombocytes. They are called thrombocytes. And clotting, meaning of clotting is coagulation. Coagulation. Okay, just keep in mind this. Also called throm thrombo thromboplastin or thrombokinase. So whenever any injury is there and in that area, or this injury of any platelet in that area, whenever the release of thromboplastin, also called thrombokinase, and in the presence of calcium ions and vitamin K is required for this. Okay, I repeat, if we talk about iron, that is a mineral iron. Question would be asked like this: which mineral is required for clotting? You should write calcium ions. Which vitamin is required? Potassium, vitamin K. क्या हो गया please? Vitamin K. Okay, this you should please keep in mind. Whatever I am writing like this would help you. Mineral iron, calcium, vitamin K. Okay, so these are always required for this mechanism. So whenever there is an injury of tissue cells or injury of platelets, the release of thromboplastin or thrombokinase, and this thrombokinase act on prothrombin. And this prothrombin change into thrombin. So whenever it is released, it works on prothrombin. It is in inactive form. Means these all things are present in blood. So when it is released, it works on this prothrombin, and prothrombin then change into thrombin. These all are working as enzymes actually. Okay, so I repeat, thromboplastin or kinase, they are all enzymes working on prothrombin. It is on inactive form, and then it is changed into active thrombin. See, prothrombin change into thrombin, and this thrombin works on fibrini. This is actually a soluble protein in our blood. These all, what I'm telling you, these all are present in our blood only. They all are present in our blood. Only these are activated. After it is released, prothrombin is present, it is activated into thrombin. Thrombin works on fibrinogen, which is present already in the form of protein, it is present in blood. And then after this, it is changed with the help of thrombin. It works on this part, and then this fibrinogen change into fibrin. It is insoluble protein. And I'm magnifying this part. Suppose this is a wood. They make fibrin fibers like this. these are fibrin fibers. These are insoluble, and when these fibers are formed here at the part of this part, so what happened? They make a network, and in this part, RBCs are blocked. When RBCs are blocked here, they form together a clot. And this part is plugged. With the net and the RBC, this part is covered, so there would be no further bleeding. And so, bleeding stops by formation of clot. Inside our body, so because what how this happens, so why does sometimes clot inside our body? Yes, actually, no, I'm telling you. This is a good question you asked me. It is relevant also. Sometimes see, it is whenever any part is injured, inside or outside, mechanism activated. Inside also, if any part is injured, the chances of clotting. But but in our body we have one anticoagulant. It is present in our body always. From liver, it is heparin. Okay, so it means even see, this is a clot form. It was a big wound, so clot is formed. After some days, below the clot, skin is formed, so we are fine. We are healthy. We, this part is healed. But whenever there is internal injuries, there are chances of again coagulation. When is coagulation, at that time, when this clot is formed inside, that is very dangerous. But luckily, we have one more mechanism. That mechanism is called anticoagulation. Anticoagulation means from liver, heparin is released, and it keep on moving our blood. With the help of this heparin, it can remove that clot which are formed inside the body. I hope I'm clear. Just answer me. Am I clear, Archika? What I explained just now? Just say yes or no. I'll understand. Any answer? Yes or no? Okay, fine. Thank you. That's good. Just wait, let me have water. So I was saying here, let us just keep in mind, whenever in our body a tissue or cells are injured or platelets are injured, one mechanism is activated. It is called clotting mechanism. First of all, one enzyme is released. It is called thromboplastin or thrombokinase. Is an enzyme in the presence of calcium, ions, and vitamin. Both are required always, and it works on prothrombin of the blood, which is in the form of which are present in inactive form. By this action, this prothrombin change to thrombin. Now it becomes active, and this thrombin acts on fibrinogen, which is always present in our blood in a soluble form. There is no problem. But after this, after the action of thrombin, this fibrinogen change into fibrin fibers, and it is insoluble. And at the site, it makes a mesh of network which block all the RBCs. Therefore, clot appears to be very red color, and then that part is plugged and bleeding stops. And after some days, a new skin is formed below, and we that victim is healed actually. Okay, so this is all about clotting. Next part, let us start. Next part, I am touching those topics which are very important and you should. Let me talk about blood groups. Let's understand this. If we talk about blood groups, there are four blood groups: A, B, AB, and O. And we have named these blood groups. Um, you know what happened? Um, Many years back, somebody, like if you talk about people, they work on this, and sometimes they transfuse the blood to the victims of wars or soldiers. In some cases of this transfusion of blood, some was saved, some of them died. So just they were very confused what is happening, that after blood transfusion, why people, some are saved, some are dying. Then they understood after some years, after so many research work of so many people, that we have different blood groups, and for any transfusion, same blood should be transfused to same type of blood group. Let me explain for this first part, blood groups. First of all, you should know there are four types of blood groups: A, B, AB, and O. And for this, antigens are required. And if you talk about RBC, suppose it is RBC, and RBC there are, means on surface RBC some structures are present, they are named as antigen, because against this only antibodies are produced, therefore they are called antigen. But, so it means, if you talk about blood, you talk, if you talk about blood, these names A, B, and O, we have named them according to some structures. According to this type of antigen, whatever antigens are present, according to these antigens, we have given different blood groups. So first of all, you should know these antigens like A type, B type, AB or AB, ABO, all are present on RBCs. This is antigen. So in blood group A, it is called A because it is antigen A is present. Antigen A. In B type, there is antigen B is present. In AB type, antigen A and B both are present, and in O there is no antigen. So actually we say O. Actually, you keep in mind as a zero antigen. So I repeat, if I say somebody is saying that my blood group is A, it means in that person's blood, RBCs are having antigen A. If somebody is saying my blood group is B, it means in that person's body's blood, RBC are containing antigen B. If somebody is saying my blood group is AB, I know, but I have some disturbance there outside, but am I still audible? But I still am audible? Fine. If you talk about a person saying my blood group is AB, it means in that person's blood, RBCs are containing both type of antigen, A also and B also. If somebody is saying my blood group is O, it means that person, in the RBCs of that person, no antigen is present. No antigen, that is zero antigen. That is called blood group O. I hope up to here I am clear. Everybody can answer. Hello, please answer. Anybody? Anybody can answer. Okay, thank you. Fine. And next part, we talk about, let me give example to, suppose it is RBC. Suppose this is antigen A, suppose. I suppose it is again RBC, and suppose antigen is like this, like a triangle, suppose. Okay. Let me give you example to you. Suppose it is antigen A and it is antigen B. Suppose in RBC, okay, on RBC. So if you talk about this RBC, there is both. It means persons having both antigen like this and like this. So AB means they are having antigen A also, B also. And you talk about this no antigen. This is about blood group with their antigen. According to this antigen, blood groups are named A, B, AB, O. And one more thing I should tell you. So this is about I'm talking about the blood part. In plasma, of A, here I'm talking about antibodies. So I want to tell you, antigens are present on RBC and antibodies are present in plasma of the blood. So blood group A has antibody B and blood group B having antibody A. We write small letters for understanding. And AB, there is no antibodies. And O, antibody A and antibody B, both are present. This you should know, okay? This is something very important. So this is something very important. Keep in mind. This is something very important to understand. I repeat, because this is something very important for yourself. So it is about yourself. It is ourselves. We know better ourselves. So if I'm saying somebody's blood group is A, it means in their RBC antigen A is present, and in their blood plasma antibodies B is present. If I'm saying somebody's blood group is B, it means that person's, if you talk about examining that person's blood in RBCs, on RBC surface there is one antigen B is there, and in the blood plasma there is one antibody named A. It means A antibody B, B antibody A. If you talk about a person with blood group type AB, it means on their RBCs antigen A and B both are present, and that to be noted, person with blood group AB, they are not having any antibodies. But you talk about a person with blood type O, they have no antigen on their RBCs, but in the blood plasma, those persons have antibodies A also and antibodies B also. And with this, keep in mind one more thing. They are called, I'm telling, they are called universal recipient, and they are called universal donor. So this is also something very important. Questions are asked in examination. Why person with blood type A are called universal recipient? Because AB can take blood from A also, B also, and AB also. Let me write somewhere. I need a space for that. So before I rub, I'm telling you again, antigens are present on RBCs and antibodies are present in blood plasma. Please note this. And next part, I'm telling this part. If you talk about blood group AB and O. As I told you, AB is called universal recipient. Recipient means a person with blood type AB can take blood from A, B, and O. If I am saying a person with blood type B is known as universal donor because this blood type can donate blood to AB also, B also, and A also. I'm showing you with this flow chart. Let us understand this. See, O is called universal donor because O is called universal donor because O can donate to blood type A, O can donate to blood type B, and O can donate to blood type AB. So O is called universal donor because persons with blood type O can donate blood to all blood groups A, AB, B, and itself. It can give itself also. So O can give blood to all blood groups. And see, B, AB can receive, AB can receive from O also, from B also, from A also. Therefore, AB is called universal recipient and O is called universal donor. So this, what I have explained just now, questions are asked on this type only. If it is understood, you can answer all type of questions, because if it is asked why AB is called universal recipient, just you draw this small chart and you can show right here. AB can receive blood from blood type O, blood type A, blood type B. And if it is asked why O is called universal donor, because O can donate blood to all the types of blood A, B, and O. And one more reason you must write. See, I hope I am audible because some disturbance is going outside. Very good, good, Achika. I'm very happy you know the answer. That's good. Okay. So I was saying, first point I told you. Second, there's one more point. Second point you write from here. AB is called universal recipient because it has no antibodies. 2 point. I repeat. First point you should write. AB can receive blood from blood type A, blood type B, blood type AB, and blood type O. Therefore, it is called universal recipient and it has no antibodies. So they can receive. And O is called universal donor because first point, it can donate blood to A, B, AB, and O. And second point, it has no antigen. And antibodies are produced against always antigen. So this point you should mention when you write your answer. I repeat, you must in here you must mention this point, it has no antibodies, and O you must mention this point, it has no antigen. Okay, next part. Blood transfusion. Let me give example to you. There is one person and there one more person. The two persons are there and this is their blood. I'm showing you. This part is their blood. This part is their blood. To understand this. And if you talk about this person, his blood type is A, and this person's blood type is B. If I say person has blood type A, it means it has antigen A and antibody B. This you know. If I say type B, it has antigen B and antibody A. This you should know about blood A type and B type. And we see, if you talk about their blood, these are RBCs and RBCs containing antigen A. These are RBCs containing antigen B. I hope to hear I am clear. Good, 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 very good. That's good. Let's take case 1. Let's take case 1. In this case, if by mistake blood A is transfused to blood B, I'm telling you what will happen. I repeat, and it has antibody B is present here, and here antibody A is present in the blood. I told you. So when this is transfused here, this is A. What will happen? First thing, whenever blood is donated, first thing in this blood, antibodies are diluted. So whenever blood is transfused from this blood is blood type A. I'm talking about this. So if this blood is transfused from A to B, from this blood group type A, antibodies B are diluted. So this would not do any effect. But problem is in the see, this part is donor and this person is recipient. What happened? This when this person receive blood from this person means blood type A. This is blood type A. These problem is problem is this. Problem is antibodies. Problem is antibodies. These antibodies A, which are already present in this person, this will make this A sticky. Will make it sticky. And because of these antibodies, these all antigens of A, which are transfused, as they would become sticky, they would clump together. When they would clump together, after some time, they will stop the flow of blood, a person will die. This problem is this. These RBCs would be clumped together because it is made sticky by antibodies of this person only. The problem is this. Therefore, if raw blood is transfused, there is clumping of the blood. It would make a clotting-like condition, or we can say coagulation of this, especially these cells, RBCs, and it would be sticky. It would clump together, and person would die because there would be no flow of blood after some time. I hope to here I am clear. I hope up to here I am clear. No answer? Okay, fine, no problem. Okay, Archika, I'm happy that you're answering. That's good. Okay, this is about transfusion. So same would happen is second case also. If I'm telling you condition, let's change the condition. If we change it, case 2, this person is recipient, this person is donor, suppose, and this is B with antibodies A. So what happened? This is B, B, and B. Say what happened? These antibodies B would make this antigen sticky, and this B RBCs containing B antigen would be made sticky by these antibodies. Actually, antibodies B make antigen B sticky, and antibodies A make antigen A sticky. So again, such this case also, this B would clump together and they would do coagulation of blood, a person would die. So therefore, we have to be very careful, and we must be very careful about the transfusion of blood. A should be given to A, and B should be given to B in all normal conditions. But in time of emergency or war, in such cases, blood from O can be given, because it is a universal donor, so blood type O can be given to all. But in normal cases, doctors see always A should be given to A, B should be given to B, and AB should be given to AB in normal cases, just to avoid any kind of problem. Okay. So class, thank you very much for today. I hope whatever explained is clear to you. Thank you very much. Stay blessed. Take care.